All right, here we go. This is problem number 55 from chapter 4 of the Halliday and Resnick book. I really like this question. It's a cool problem. It says a ball rolls horizontally off the top of a stairway with a speed of 1.52 meters a second. The steps are 20.3 centimeters high. I'm going to right away rewrite that as 0.203 meters, right? Because we don't like centimeters. And then same thing here, right? So the steps are 0.203 meters high and 0.203 meters tall, and then we got to figure out which step the ball hits first. All right. I looked in the solution manual to see how Halliday and Resnick did this, and I did not care for their solution. I think that this is a little bit easier. All right. So check it out. Here we go. Let's draw our steps. Step, 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 step. All right. So the ball is going to be sort of rolling along this way with an initial velocity of 1.52 meters a second, right? Because it's moving horizontally. And the ball is going to go off of the steps, right? So it's off the steps, and it's going to go and land down here somewhere, right? Okay. So that's sort of one thing we need to be conscious of. All right. So what I'm going to do is this. Let's call this our origin. Okay. So if you kind of imagine, our coordinate system going like this. What we really want to figure out here is at what moment in time does the ball cross this line, right? So if it crosses here, it'll hit, sorry, I'm pointing, you can't see where I'm pointing. If it crosses here, it's going to hit the first step. If it crosses here, it's going to hit the second step, etc., right? So that's the deal, all right? So that red line right there, because our steps are just as tall as they are wide, that means that the slope of this red line that I just drew is -1, right? So that red line that I just drew is this line. It's the line y equals -x, right? So in other words, if you go over 1 meter, you're going to go down 1 meter, right? Okay. So let's do this then. So let's go back to the projectile, the ball coming down, and let's write out what we know. So here's what I know. I know that at any given instant, my horizontal position at any given time is going to be this horizontal velocity, 1.52 meters a second, times the time, right? And vertically, I know that my position at any given time is 1/2 of -9.8 meters a second squared times time squared, plus my initial vertical velocity is 0, right? My VOY is 0, okay? So this is just, if you missed that, this is just this equation. We know that, vertical position is 1/2 vertical acceleration times time squared plus V0y times t, okay? So this black line, this black curve, is described by this parametric sort of system of equations here, right? And we want to know when it crosses this red line. So what I'm going to do is I'm going to set them equal to each other. So at the moment when the black line crosses, the black curve crosses the red line, my y is going to be equal to -x. Okay, so here we go. Y is going to equal -x. So I'm going to say 1/2 of -9.8 t squared is equal to -1.52 t, -x, right? So this is y equals -x. Okay, and solve it. So let's see, the negatives cancel, so I'm looking at 4.9 t squared equals 1.52 t. So let's see, one solution is 0. Oh, that's right here. So let's divide by t. You get 4.9 t equals 1.52. Divide both sides by 4.9, and you get that t equals 0.31 seconds. All right, cool. Well, so now let's just figure out how many steps that is. So at that instant, my position at 0.31 seconds is just 1.52 meters per second, sorry, times 0.31 seconds. And so that is 0.4715 meters. I'm being really sloppy about my significant digits here on the board. I did keep track of them as I worked through this. All right, so 0.4175 meters, and each step is 0.203 meters. So I'm going to do some old school factor label times, let's see, one step horizontally is the same as 0.203 meters. So multiply that out and you get 2.33 steps, which means it's going to cross this red line somewhere between the end of the second step and the start of the third step. Bam, it's going to hit the third step. All right, there you go. Hope that was helpful.